Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will learn the Sketcher Workbench. It is an introduction tutorial for a FreeCAD Sketcher Workbench, and we will learn how we can utilize the FreeCAD Sketcher Workbench with a different workbench. Like we can create a sketch with a Sketcher Workbench, and we can use it with a part design workbench as well as part workbench. So for this tutorial I am using the FreeCAD version 1.0. so you must have a FreeCAD version 1.0 or higher version of a FreeCAD for this tutorial. Use of a FreeCAD Sketcher Workbench is to create 2D sketches that can be used with other workbenches. 2D sketches are the starting point of any CAD models. Without the 2D sketch, we cannot create a 3D model. Sketches typically define the profile and path for the operations to create a 3D shape. A model may be depend upon several sketches for its final shape. Here is a simple example of a 2D sketch created with a FreeCAD Sketcher Workbench, and if we see here, this sketch is of a green color, which means that it does not have any degree of freedom. So once we create any sketch, it must be fully constrained, and you can see the constraint symbols here. Like we see the equal symbol, which means that this line and this line is equal, this line is of a vertical, and here is a tangent constraint, which means that this line and arc having the tangent relation. Now we can also use the FreeCAD Sketcher Workbench with a part workbench. The Sketcher for the to create a constructive solid geometry and to build the solid model with a part design workbench. Now if we see in FreeCAD, if we activate our part design workbench, we get a Sketcher Workbench inside of a part design workbench. But if we expand it, we can see the Sketcher Workbench is a different workbench which is integrated with a part design workbench. Now let's switch to the part workbench, and here in the part workbench we can also see the Sketcher Workbench, which means that we can access FreeCAD Sketcher Workbench independent, or we can use inside of a part design and part workbench. Now let's switch to the part design workbench, and let's insert a body and on the origin plane, and now select the top plane, and let's activate this Sketcher Workbench. So once you activate it, you can see that Sketcher's Workbench tool is active. Let's hide this origin plane. Now we will understand these tools, what are these tools and how we can use it. So if we see the Sketcher Workbench, so here is a sketching tools like a point, polyline, line, and the arc. We can see the multiple arc options. We can see the multiple options to create a circle. Here we can see the multiple options to create a rectangle, and here we can see the multiple options to create the pentagon, hexagon, square, triangle, etc. And here is a two options to create a slot, and here is a spline curves to create it, and this is the to toggle the geometry like a continuous or a reference. So these are the draw tool and these are the constraint tools. Sketcher Workbench features constraint allowing 2D shapes to follow the precise geometrical definition in the terms of length, angle, etc. A constraint solver calculates the constraint extent of a 2D geometry and allow the interactive exploration of a degree of freedom. Now let's understand the what is the degree of freedom. So to understand this, let's create one rectangle here, and now you can see that FreeCAD automatically applies this vertical horizontal constraint, and now if we try to move it, we can move it, which means that it have the degree of freedom, and we have to make degree of freedom 0. Now let's constrain this rectangle, and we will see how this degree of freedoms works. So our sketch is white. Select this smart dimension option to give the horizontal dimension. So let's make it 50 and make this vertical also 50, and now we will move it. So here we will define this point from the origin. So now we see that under constraint 2 DOFs. Now click on it, so you will see the points. So if we constrain this point from the origin or this one, our degree of freedom will be 0 and our sketch is fully constrained. Now here DOF is showing 2, but if I delete this dimension, so DOF is a 3. Now if I delete this one, DOF is a 4, and let's also delete this horizontal constraint, so DOF is 5. So you can see that if I am deleting the relative constraint, my DOF is increasing. So here is a 8 DOFs. Now let's reduce this to the 0, and once we apply the constraint we will see it reducing. So first let's apply the horizontal constraint. Apply this horizontal, apply this vertical, apply this vertical. So here if we expand it, we can see the separate horizontal and vertical constraint. If you select these options, FreeCAD solver automatically detect whether line is a horizontal or vertical. So you can see that we have applied the 4 constraints. So now you can see that our degree of freedom reduced to 4. It was 8. We have applied the 4 constraint. Now let's apply the dimensions. So this is the 50, so it is now become 3. Let's apply the vertical dimensions. Now it is 2, and select smart dimension and select this point and make it 20. So now it is 1. So now if we apply the vertical dimensions and let's make it 20. So you can see that fully constrained and our DOF is a 0. Since it is 0, therefore it is not showing. And you can see that our sketch constraint color is changed to green, which means that it is a fully constrained. So this is how constraint and degree of freedom works. Now here we have created a sketch. Now if we close it and we will create a simple pad, so you can see that sketch is inside of it, and if we on our sketch we can see the sketch here, but we will not see the constraint. If you wanted to see the constraint of a sketch, then select the sketch and edit it. So this constraint will not be visible once you created the solid, but you can on and off the sketch by pressing the spacebar key from your keyboard. Now let's delete this pad. So if you wanted to create a 2D sketch and you do not want to create a solid, then instead of this Sketcher Workbench, use the Draft Workbench, which is very useful workbench for creating the 2D sketches, and you can export those sketches into the DXF file, and you can modify that sketch in softwares like AutoCAD, DraftSite, QCAD, etc. Now let's edit the sketch and see some more option inside the Sketcher Workbench. So here under the smart dimension you will see the different type of dimensional tools like horizontal, vertical, aligns dimensions, constraint radius, constraint diameter. So let's create one circle here, and here I will select a smart dimension, so it will automatically detect that it is a circle, but you can select a diameter constraint and you can specify the diameter. So now once we give the dimension, we will see here some options like this is the diameter and here is a value, and let's make it 100 mm. Name is optional, you can give some name to your dimensions. To link the dimension, we will see these options in upcoming lectures, how we can use it to the link the dimension. And here is a reference dimensions. Reference dimension are extra dimension which we can give to our drawing. Let's say okay. So if you wanted to make this dimension as a reference, then see one example. For example, here I have given the diameter 100, and let's select the smart dimension and constrain this circle to the 200 distance, and let's provide the vertical dimensions and make it 100 mm. Now here I wanted to give the radius as a reference dimension, so let's select a smart dimension and from here select constraint radius. So here you can see that this constraint is a redundant constraints, which means that this is an extra dimensions which FreeCAD not allowing me to do that. So here I will click on the reference and say okay. So you can see that reference dimension is created. This is an extra dimensions. Now for this circle I wanted to give the radius, and I wanted to make this 100 diameter as a reference. So what I will do, I will edit this dimension and make it a reference. Now here if we see this both dimension are a reference, then we have the 1 degree of a freedom. Now here I will make this reference dimension as a default dimension and say okay, and degree of freedom is removed. So this is basically an extra dimension. Some people prefer the radius, some people prefer the diameter, so that is an optional dimension you can give. Now let's understand the dimensional part. So let's consider this 200 dimension. To edit the dimension, all we have to double click on this 200 and change the value. Let's make it is a 210, and now this dimension is also recorded in a solver message here. So let's select the 210 dimension and scroll down. So you can see that this is the horizontal dimensions and it's having the number constraint 14, in here is a value 210. We can also edit the dimension by clicking on here. So we can directly edit from here by double clicking, or we can also click on here. Now let's click on this circle. So here under the elements sections you can see that this circle is got highlighted. If you uncheck it, it will be get hidden. For example, this tool is very helpful if you are creating very complex sketch and you want to hide something for a temporary basis. So this way we can hide it. For example, let's hide this square as well. Press Ctrl key, select all. So once you select here, everything is going to be select here in a browser as well. We can see that, say that this is a overall property of our sketch. Now if we uncheck it, this will be also hidden. If you wanted to on it, just check it, you can on it. So this is how we can hide the constraint and we can hide the element as well. Now let's learn how we can validate our sketch. So for example, I will delete this circle and I will close it. Now if I select my sketch and go to the validate sketch option and click on the highlight troubleshoot vertices, so you can see that it is highlighting because nothing is open. Now we will make one error in our sketch. We will delete this line and we will draw one line, and from this point to this point let's provide the gap 0.001. okay, and select the dimensions and same provide here 0.001. Now our sketch is fully constrained, and let's come out of it and let's try to extrude it. Select the sketch and click on the pad. So we cannot pad it because our sketch is not valid, and from top view if you see the sketch, we cannot find that it has an open loop because we have created very small gap here. So identifying such type of open loops is very difficult, but do not worry, FreeCAD having tool to detect it. So we have the open area at this position, so we will select our sketch and click on the validate options and click on the highlight troublesome vertices. So you can see that FreeCAD is highlighting here one point, which means that it is the problematic area. So now let's close it. We have identified the problems, and now let's select it and delete it, select and delete it, and now let's zoom it, select this and add a coincidence constraint. Now close it. Now we will again validate it. Now we will not see any problem, and if we try to create a pad, we can successfully create a pad. So this is how, when you create a sketch in FreeCAD, you must validate it. Do not proceed further for the pad, revolve or other solid features, because if you not validate it, you will not be able to find the problem in your sketch. So keep this a standard practice. Create a sketch, validate it, and then go for the solid modeling features like a pad, revolve, groove, etc. Now learn some more techniques to create a sketch. So let's create a circle. Now here we can create a circle, and then we can provide dimensions. Like I have created a circle, and now I will provide 100 mm. To save the times, you can directly enter this value. Let's delete this circle, create a circle, and now if you see that as I am increasing or decreasing my mouse positions, my diameter value is changing. Now here I can directly put the 100 mm and press enter. So you can see that rather than creating a circle and then providing the dimension of a diameter 100, I have just entered that value while creating the sketch. So once you become the pro user, then you can utilize these tools and it will be much easier to create a sketch and save your time. But for a time being, as a beginner user, you follow the normal method. Just create a profile and then constrain it with dimensions like horizontal, vertical dimensions, and this works with a line as well. If I wanted to draw the line of 100 mm, then you can see that as I am moving the line, my length of a line is changing. So if I wanted to create a line of 100 mm, then I can directly provide the 100 mm, and here press the angle 0 because I want it horizontal. So you can see that it is created. Or in a simple way, you can create a line of any length and then you can fix it with dimensions. So both the methods are okay, and it depends for which method you are more comfortable. Those who have used the tools like AutoCAD, they are very comfortable with entering the values while creating any profile, either line, arc, circle, rectangle, and it also works for the rectangle as well. So let's I want a horizontal distance of 100. Press the tab key so that it will switch to the vertical dimension and 50. So here I wanted to create a rectangle of 100 by 50 and I have enter the value and say OK. So you can see that this angle is created, this dimension is created, and also constraint has been applied. So this is the all about the basic overview of the constraint tools and profile creations tools like a line, arc, circles. So this is the fundamentals tools of a FreeCAD Sketcher Workbench, and we have also learned the DOFs, we have learned the constraint and elements, and in upcoming lectures we will create a profile and we will see some advanced tools in FreeCAD like symmetricity, tangency, perpendicularity, parallelity, constraining, and some profile example with reference geometry, trim, extend. So this is the introductions to the FreeCAD Sketcher Workbench, what it is and how we can utilize it with different workbenches like a part design and part workbench, and at the same times the fundamental concept of a FreeCAD Sketcher Workbench is a degree of freedoms and this validate sketch options. So if you create a sketch by considering these DOFs and know any open loops, so you will not face any problem while creating the 2D into the 3D. So this is all about this tutorial. Thank you for watching and thank you for your valuable time. And now we will come back to our tutorial.